Hello all, my name is Haonan. I'm currently a master candidate working at the Life Cycle Management Laboratory, supervised by Dr. Kasun Hawaki and Dr. Rehan Sadiq at the University of British Columbia. Today, I'm going to discuss the presentation on exploring the trade-off between environmental and economic impacts of building energy retrofits. In the recent years, the government of Canada has established ambitious targets to reduce greenhouse gas emissions in multiple sectors. In the building sector, British Columbia has introduced the BC Energy Step Code to reduce energy consumptions and associated emissions of buildings. However, the focus is on new constructions, and the limited guidelines and policies available for the energy performance of existing buildings. Nevertheless, the energy consumptions and the emissions of existing buildings are generally more than new constructions because of deteriorating building materials and low-efficient energy equipment. Therefore, it is important for us to reduce energy consumptions and the emissions of existing buildings. As such, this research aims to develop a decision support framework for energy retrofit planning in the residential building sector, accounting for lifecycle environmental and economic performance. The overall methodology of this research includes the following steps. First of all, we conducted the data collection on lifecycle assessment and cost databases in order to obtain the embodied emissions and the initial cost of different retrofit components. The collected data were used for the following lifecycle assessment and lifecycle costing. The overall lifecycle analysis include the following steps: goal and scope definition, inventory analysis, impact assessment, and interpretation. The calculated lifecycle analysis results were considered as inputs for the multi-objective optimization. In particular, by coupling building energy simulation tools, HAL 2000 software, and the H-type energy simulation packages, and the retrofit optimization tool developed in the Python coding environment, we performed a multi-objective optimization of different retrofit packages. Look at this figure, we can see the optimization results of this research. So when we look into this figure, we can see that the blue points represent the possible retrofit solutions, while the red points represents the identified Pareto optimal retrofit solutions. So for example, look at the solution A. If we choose solution A, we could strike the perfect balance between life cycle emissions and the life cycle costs according to our decision priorities. Let's look at another example. The solution B represents the eco-friendly solution. It can achieve the least life cycle carbon emissions. Therefore, policymakers should pay more attention on this solution to obtain the most environmental benefits. Furthermore, the solution C represents the cost optimal solutions. It can achieve the least life cycle cost. This solution can assist homeowners to most effectively reducing energy costs, and it is also beneficial for the environment. So look at this table, we can see that by utilizing our multi-objective optimization framework, we can identify the different Pareto optimal retrofit solution for different building archetypes at different investment retrofit cost. When it comes to the deliverable, we have completed a research article of lifecycle thinking-based energy retrofits evaluation framework for Canadian residents. When it comes to the findings of this research, firstly, we conclude that lifecycle assessment and lifecycle costing can provide comprehensive environmental and economic analysis for building energy retrofits. In addition, the proposed framework can assist the decision makers in identifying optimal retrofit solutions at different investment costs. Then the decision makers can find an optimal balance among their expectations when implementing optimal retrofit solutions. Finally, the proposed framework can assist policymakers in developing retrofit strategies. And in the future, we would like to develop a user-friendly tool for the industrial applications. So this is the presentation. The detailed information is provided in this research article, which is currently under review with a journal. Please refer to this paper once it is published. Thanks for watching.